to cover from a really rich and wide range of work covering the globe. So let me just introduce myself and some of the work that we're going to present. So for those of you who don't know me, I'm Tom Smith. I'm the director of the Data Science Campus at the UK Office for National Statistics. I'm also the vice chair for the UN Committee of Experts on Big Data and Data Science, which is the group partly hosting and supporting this webinar and the other webinars alongside. But before I go further on that, let me really give a huge thank you to the UAE team who are hosting this webinar as part of the Expo 2020 program and the road to Expo 2020, which there'll be 3 webinars coming up over the next few weeks, hosted by the UA team and also the Big Data Committee of Experts. And I really want to thank some of the UA team by name. So His Excellency and the team. So His Excellency Omar bin Sultan Al Lama, and we will hear from some of the team there, but also Her Excellency Thuraya Al Hashimi and Latifa Al Shehi, and the whole UAE team who have been fantastic partners in really this exploration and journey of using big data and alternative data sources for improving our statistics and strengthening our analysis as part of the global statistics community. So let me give alongside those thanks, a quick word of scene setting, of context, before we go into the talks. We're really looking here at how we use alternative data sources, big data sources, to add and complement and strengthen what we can already derive from our current sources that statistics and official statistics use and know well. And you may be able to see my backdrop, which is a screenshot of both Brighton in the UK, the city that I live in, but also the Census 2021 programme, which was just completed earlier this year in the UK, which was extraordinarily successful in terms of response rates and the quality and the depth of information that we produced and captured as part of this. And big data sits alongside all of our traditional sources like surveys, census, and so on, alongside all of our other government administrative data sources. And so it's a really part of a bigger picture. And I hope that today we'll see how big data and alternative sources can really add to what we know and the strength and the quality and the value of our statistics and our data and our analysis in terms of informing decisions by governments, by businesses, by industry around the globe. The second point I want to make is that this webinar really focuses on the UN Global Platform. This is a program that was piloted as part of the UN Global Working Group on Big Data, alongside ONS in the UK, and was recently or last year handed over to the UN Statistics team led by Ronald Janssen. And I'd really like to shout out and say thank you to Ronald and the team at UN Statistics for all of the support, input, and the drive to really scale the UN Global Platform to a truly global enterprise. And so some of the examples we'll see today are work on the platform, which is about supporting innovation, experimentation with new data sources, but then also about supporting scale up, reuse very rapidly by countries and statistical organizations around the world. So what one of us learns, all of us can use. And I think that is a great a touch point for all of us to think about when we think about the global statistics community and how we can support all of our endeavors in terms of understanding what's happening in our economies, our societies, and in the environment. So this webinar is about the UN Global Platform, and we will look very quickly at some of the coverage and the work going on, looking at data sources such as shipping GPS, data sources such as satellite imagery, and then a demo and examples of the platform in action before we finish with some thinking and thoughts around what is the future of the platform and the future of the program that we're looking at here. So I think that was all I wanted to say in terms of introduction. I've covered some of the work that we're going to see in the next sort of hour and a half. And we have an excellent lineup of speakers, so I'll introduce them as we go. And I really look forward to hearing your comments and and questions and so on as we're going through the sessions. So I will pause at the end of each slot and invite questions from the group. So please do come forward and put things in on comment and chat. So let me pause there and hand over. And first of all, I would just like to sort of make the point about the platform is supported by a group of regional hubs. This is where the UN Global Platform is really supported and works with the regions around the globe. And the United Arab Emirates Hub is supporting in the region here, is really helping to drive forward and start up some really exciting work. So before we go any further, let us see and hand over to the UAE team on the hub. And I think we have a video which will show some of the work and the thinking going on and how this lands in with the Expo 2020 program. So I believe this video is started up or getting ready to play. So Clarence, if you could start the video, please. Many thanks. And I'd now very, very pleased to introduce the UAE team. And I believe that there is a welcome from His Excellency Omar bin Sultan Al Ulama. So I would like to hand the floor to His Excellency.
Thank you, Tom. Thoraya Al-Hashimi, I will be speaking on behalf of His Excellency today. Respected guests, ladies and gentlemen, good afternoon from Dubai, the United Arab Emirates, and welcome to the launch of the first Road to Expo 2020 webinar. As we learn to live with a changed world and rebuild from COVID-19, some things remain consistent in the UAE. We are committed to ensuring that the right partnerships are in the place to promote sustainable development between communities and across the border. In a few weeks, the UAE will be celebrating its 50th anniversary, and in every occasion, our leadership emphasizes the importance of building strong, innovative partnership with the national, region, and international organizations and institutes, not only for the knowledge transfer, but to broaden the horizon, to embrace new opportunities, and to be well prepared and agile, well occupied to develop a sustainable digital economy by keeping the pace with the global changes. Today, at the Federal Competitiveness and Statistics Center, mark an important milestone by inaugurating our strongest platform in collaboration with the United Nations Committee of Experts on Big Data and Data Science for Official Statistics. We are proud and honored that our success story continues together by enabling big data as a true meaning of empowering people and transparency. One of the most important assets to countries is data. The UAE, we have embraced the strategy to enable this wealth of information and data to decision and policymakers, to the community, and to the private and public sector to help generate a public value, thus ensuring a wider national economic development and diversification towards a successful digital economy. As the world opened the gates for researchers, developers, legitimate community members, we are in the UAE believe in the importance of having a robust infrastructure and platform that provide open data. This is to ensure that efficient and continuous use of resources, which can help identify development opportunities to individual, private, and public entities for a better, sustainable, and successful future. To achieve the Sustainable Development Goals, enabling big data are vital to develop the know-how of communities, individuals, who are the main drive in introducing methodologies and creating innovative culture. Throughout the 4 webinar series, The Road to Expo 2020, we aim to learn from the professions in this field of data science and AI and share the learnings and insight with the nation. I truly look forward to welcoming you on the 19th of January at Expo 2020 Dubai, when we will celebrate the official launch of UAE Data Hub. Thank you very much.
Many thanks for that welcome, and my apologies. Let me introduce you properly now. So, Her Excellency Thoraya Al Hashimi, who is the Executive Director of the Digital and Data Enabling Sector. So, really thank you for that fantastic welcome. So, we have a great program here, and as I said in the introduction, this is one of a number of webinars covering some of the big data work on the road to Expo 2020 and the January 19th event that Thoraya just outlined to us. And some of the points just made, I think, really set the scene. So this is about using big data to understand and support decisions, but really to improve and strengthen our knowledge of the world and what is happening in the economy, what's happening in society, what's happening in the environment. So with that, I'm really pleased to hand over to our first speakers on the program. And this is the work entitled Tracking Trade from Space, so an application to Pacific Island countries. Let me welcome Serkan Aslanalp, who's Deputy Division Chief at the Balance of Payments at the International Monetary Fund. Also Robin Köpke, economist at the IMF also, and Jasper Verschoor, the Environmental Change Institute at the University of Oxford. So Serkan and colleagues, the floor is yours.
Thank you, Tom. Let me first try to share the screen. Can you see it?
Yes, perfect.
Okay. How about now?
A security alert add-in.
Okay. How about
now? You're
now?
good. That looks good.
Good. Okay. Excellent. Well, just give me 1 second. Thank you very much, Tom, for chairing this meeting, and many thanks to the organizers for having us today. Special thanks also to Marky and Ronald for their support with the UN Global Platform. The title of our presentation is Tracking Trade from Space, an application to Pacific Island countries. This is joint work with my colleagues Robin from the IMF also, and Jasper from Oxford University. It is the result of a multidisciplinary, work, as we are coming at this with very different backgrounds in some sense. I have some background in the region, having worked there as an IMF mission chief and now working in the statistics department on issues related to big data. Robin is currently working in the region and has done a lot of work tracking capital flows in real time. And Jasper has background in engineering and has done very interesting work on the criticality of ports for the global supply chain. So we're very pleased to be here. And once again, many thanks to Tom, the organizers, Marky and Ronald, for the close partnership with the UN Global Platform. So the structure of today's presentation will be...
Serkan, I'm just
yes.
going to interrupt. Your screen has gone off full screen. It's gone back to your slides view.
Let me try again.
Yes, that's good.
Okay. So I'm just going to have to try a little bit because there are two things going on here. Unfortunately, I have only one screen. Is this okay? Are you still able to see it? Tom? Hello?
Yeah, Serkan, no, this is again your slides. So you had the presentation mode earlier, but not at this point.
Okay. How about now?
This is good. This is good.
Okay. All right. Let me try with this. Okay. So today's presentation will revolve around four parts. I'll briefly give a brief introduction on the motivation for this study, and very brief remarks about the Pacific Islands, some stylized facts about the Pacific Islands. Then Jasper will talk about the methodology and the data, and Robin will provide we'll talk about the application of the study to Pacific Islands during 2020 during COVID-19. And I will conclude with some possible extensions of the work. Okay, so very brief motivation. I think as everyone, most everyone in this audience know, satellite data are increasingly being used for economic analysis. Donaldson and Storygard has a piece in the Journal of Economic Literature in 2016, which talks about watching the planet from above, and talks about the revolution in sensors and computer science and economics and geography and how all these things are coming together. And so we essentially see this work as an application of this approach for merchandise trade and in the Pacific region. You may wonder why we picked the Pacific Island countries. Well, it turns out that it's actually quite an ideal case for this kind of study. Just a few stylized facts about the countries in the region. They are all small open economies, vulnerable to climate change and natural disasters. They are remote and dispersed islands served by a few container lines, so-called sea-locked countries. They have few trading partners that make the islands vulnerable to external supply shocks. They depend largely on imports of raw and manufactured goods for both consumption and investment. They have a few ports which serve as the main gateway to economic activity and lifeline after global or natural disasters. And most importantly, perhaps they have very limited statistical capacity as measured by the World Bank Index of Statistical Capacity, which hinders timely production of essential data. Essentially, they don't have any data on trade volumes, which we provide in the study. Let me immediately move to the contributions of the study. We see our contributions as threefold. First, using the satellite-based vessel data, we construct high-frequency indicators of economic activity in what we call a data-scarce environment. These are small, fragile states, and we see this could be used for either country or regional surveillance by the IMF, by the ADB, by the Secretariat of the Pacific Community, but also by, of course, the country authorities themselves. Second, we advanced the estimation techniques of previous studies, including some that both Jasper and I had done previously, particularly by employing ways to overcome past challenges with the estimation of cargo payloads. Second, we incorporate detailed information on shipping liner schedules to validate port goals. Third, we incorporate domain expertise to validate trade estimates. And finally, we apply country-specific information to define port boundaries. And final contribution, as we see it, which is especially important in my institution at the fund, that there's a lot of demand for this kind of analysis, but the data is quite expensive. So we try to provide an easy-to-follow approach that can be replicated by country desks at the fund, but also others, that does not require a commercial data budget. So because this UN Global Platform is being made available to public institutions, we are very fortunate that we could do this analysis without a commercial data budget. And secondly, we provide an algorithm that underlies the study so others can extend it for their purposes. I hope that provides a little bit of introduction. I will now pass the floor to Jasper.
Yes, thank you, Serkan. So I would like to start by providing a brief overview of the automatic identification system data, or just short AIS data that we use in this paper. So in short, it can be seen as an air traffic control system of ships globally, which was introduced in 2004 by the IMO to improve safety of navigation at sea. And nowadays, it's basically mandatory for all ocean-going vessels to have this installation at their vessel. So data is, as Sarkon said, usually provided through commercial providers, which makes it very expensive to use. But as Sarkon said, the UN Global Platform made this data available to us and other government organizations or academic institutions for research purposes, which makes this ideal. So the AIS data is collected by both satellites and terrestrial receivers that retrieve information from these vessels every few seconds to minutes. And this information contains both dynamic information, such as the location or speed, static information about the vessels, such as the size or the type, and sometimes voyage-related information, such as where it's going. Next slide, please. So given the size of the raw AIS data, which can be several terabytes, one needs to extract the exact information that is fit for purpose and manageable in size for your research purpose. For instance, by setting a specific port boundary or a time period of interest. So in our work, we try to narrow down the data requests by first only selecting vessels that are being used within the liner network of the Pacific, as you can see in this figure in the top, which we got from official liner schedules. And second, we collected data on specific vessels within predetermined port boundaries, which we drew ourselves, and this considerably narrowed down the amount of data we needed. To derive port calls from this, we wrote a simple algorithm to determine how vessel movements in these port areas translate into port calls. And this port call information we then merge with additional vessel information such as the design characteristics and the carrying capacity, which we later on need to estimate trade. So just short, we in the end ended up with more than 450 vessels serving 30 ports in 11 Pacific islands. Next slide, please. So we have this, and in order to know whether a port call algorithm actually worked, we conducted a number of in-depth validation. So first, we compared our port call data with official port call data that we found for Fiji, Nauru, and Samoa, which gave us a perfect fit for Fiji and Nauru, and almost perfect fit for Samoa, which gave us confidence in our work. Second, we matched the derived liner schedule from the data with official schedule information from the 3 main shipping companies in the region, which also showed a good match. And third, we sort of like did a sense check to see if the port calls by ship type make sense. For instance, if bulk carriers only visited Pacific ports that are known to be commodity exporters. Next slide. So to estimate trade after we derived the port calls, we used the dynamic information in the AES data together with the vessel characteristics. So it mainly relies on the vessel depth information over time, which is manually updated by the crew and therefore may include some errors. So very briefly, to estimate trade, we had to derive the vessel utilization rate when it was entering and leaving a port, with the difference between the trade going in or out. When the outgoing depth was not updated by the crew, we were able to get around this issue by backpropagating the depth from the next port of call, as it's often updated at that point in time. And if this still wasn't possible, we looked at the historical record and used the historical average to fill in the gaps. And this provides us with a proxy of trade volume associated with every port call in the record. Next slide. To get a sense whether our derived trade estimates provide us with a good proxy of relative changes in trade, because here we're mainly interested in relative changes, we collected official trade data for 4 countries for 2002. It should be kept in mind that this is another direct comparison because the official trade data is in value terms, whereas our data is in volume terms, and because of the timing between customs data and our data might be slightly different. Due to this caveat, we should not expect a perfect match here, but as you can see in these figures, the curve or the pattern that we observe is very similar than the official data. Gives us, again, some confidence in our work. Next slide. And at last, we did some additional sense checking by collecting all data we could find for countries for 2019 and 2020, which included monthly data for 7 Pacific islands. And here we set up some simple regression formulations to see if the official data in absolute terms scales with the derived data we came up with. And in the end, it's around 90% of the variation in the official trade statistic we could explain with our derived data. So what is now great about this AES data, we can fill in data gaps at different countries and look at trends and turning points on shorter timescales than the official data, which is obviously often monthly. For instance, we could look at weekly proxies of trade to identify short-term shocks to the regional trade or transport network. So now my colleague Robin is taking over to discuss application of the data for Pacific Islands during COVID-19 pandemic in 2020.
Thank you, Jesper. Yes, so we apply this methodology to study what happened in Pacific Island countries during COVID-19. And in particular, we look at the evolution in 2020 and how it compares to the previous year in terms of import dynamics to Pacific Island countries. Now, it's worth highlighting that PICs were actually quite successful, very successful by international standards in insulating themselves from COVID-19 infections. They saw very few infections for most of the period of COVID-19, but they were not insulated from the trade and economic repercussions. So in the analysis, we find that there were essentially two stages. One was the early stage where supply effects disrupted trade and in particular imports to all Pacific Island countries. But then in the second later stage, we see a differential evolution depending on the tourism dependency of Pacific Island countries. So in the next slide, let's start off with the big picture. We have on the left a chart of the official data for countries that make available data. Those are the 4 countries listed below the chart. And then on the right, we have our estimates, which are in volume terms, the left chart in value terms. And the first observation is that we do observe broadly, very similar dynamics between the official data and our own vessel-based estimates. And so, in the early stage of the pandemic, which is highlighted here in the gray box that goes to about May or June of 2020, in that period, we see a significant decline in imports across Pacific Island countries, which we argue is primarily driven by supply side effects, including restrictions, port restrictions by China and other countries that were affected early in the pandemic. But then when we look at the next slide and the following slides, we'll see that the subsequent evolution depended a lot on the economic structure of Pacific Island countries. So here you have 2 charts on tourism in PICs. The chart on the left shows you that there was essentially a collapse in foreign visitors coming to PICs when the pandemic escalated in March, April 2020. So tourism for most PICs has been essentially zero since that period, since around April 2020. And you see in the chart to the right, first, the blue dots show you the percent change over a year earlier in visitor arrivals, which is shown on the right-hand scale. So you can see essentially all these Pacific Island countries had drops in tourism of around 80 to 90%. But when you focus on the orange bars, the economic impact varies widely depending on how much tourism they had in their GDP. So for, let's say, the 4 countries on the left, Vanuatu, Fiji, Samoa, Palau, those are highly tourism dependent countries. Yeah, so we can go on the next slide and see what the what that does in terms of trade dynamics. So for tourism dependent PICs, we saw a very sustained import drop. So you can see here, the 3 lines. One is for the black line is for tourism, for low dependence on tourism. It's basically an index of those countries that have low dependence. And then in blue, you see the countries that have a high dependence on tourism. In the early stage, we see a consistent decline in imports across countries, but then we have this differential evolution where tourism dependent countries see a much more protracted impact. And it's worth noting that this pattern is also corroborated by official data for those countries that have made available such data. And we also observe this same pattern for those countries that, in our estimates, for those countries that have not made available the official data yet. So it's a very consistent pattern in the data set. Next slide, please. So just in terms of takeaways, if we link this to the recent literature on how the pandemic has affected growth, overall the global effects were largely tied to consumption shocks, investment shocks, but also exports, including tourism. And our estimates suggest that peaks were mainly affected through this tourism channel. And this is also consistent with some of the recent literature, which is listed at the bottom here for Seri and others, and Gian Maria Milesi Ferretti. Both of them had studies showing the GDP impact for tourism-dependent countries, which was much higher than for others. And then the IMF's latest external sector report also shows this pattern for the impact on current accounts. So with that, let me hand over to Serkan.
Thank you, Robin. Maybe all that remains for me, and I will try to just wrap it up in a minute, are just possible conclusions and possible extensions of this work, which we detail in the paper, but just maybe as a very brief overview. We think that this work could be extended to other small island states. About a quarter of the IMF membership consists of small states, and a lot of them have large data gaps. Second, there are obviously a lot of global supply disruptions happening around the world, including a recent one that happened in the Suez Canal. With a focused, with some focus on these kinds of areas, this approach could perhaps also help answer some of the questions that may be related to the things going on at the moment. And importantly, we think that there's a lot of use for this for cases that have to do with climate change and natural disasters. For countries that are vulnerable to climate-related natural disasters, port disruptions could be quite macro-critical, and we plan to do a little bit more work on that going forward. So maybe it's better for me to stop there and see if there are any questions.
Serkan, Jasper, Robin, thank you very much for this. This is an excellent outline of some really interesting work. We could have some couple of minutes for some questions, and there are questions coming in the chat, so let me relay them. First, can you say something about plans to extend and expand this to other countries? And then secondly, can you say something about whether the data might be used to or feasible to estimate informal trade levels? Back to you, all.
If I can take the first question. So extending the work to other countries is something that we've been thinking about. There's already some interest from country desks in our institution for extending this work. Also, we've been in some discussions with the ADB to possibly extend this to Asian countries outside of the Pacific. And we see this as a bit of a demand-driven approach, where if there's a specific need coming from a region or a country, that we are ready to support them through the algorithm that we provide with the paper.
Yeah, I can take the second one, Serkan. So informal trade is in many ways a bit more difficult because these transmitters are mandatory, but in the end, it's very difficult to check if people actually, first of all, have them. The other thing is people can turn them off. There's like for normal trade, there's no reason why you would do this, but there's a lot of cases people working with this data with respect to fisheries, especially illegal fisheries, where they found out that a lot of like fishing boats, when they enter fishing areas that are like where they're not allowed to fish, they turn off the AES retriever. So how they go around this is sort of merging information on AES data with satellite information to sort of like fill in these blanks and come up with some sort of similar approach on informal trade. But it's much harder, and so it's definitely possible, but yeah, very hard to do in practice.
Thank you very much. I'm glad you had a go at the informal trade and very much recognise the difficulties of that analysis from any data source, obviously. A couple more questions, and one is a link to perhaps make with ESCWA, who are also looking at AIS data and Suez Canal and weather extremes impact on the shipping traffic. So it might well be a link to make if you've not already. Secondly, slides just for all attendees. We will put all of the slides from all of the talks up on the website after the webinars so that you can follow there and pick those up again. And also this session is being videoed, so that video will also be made available. So a couple more questions. Could you use a similar approach to estimate typical routes of vessels? Is that something that you could look at? And then there is a question around illegal trafficking through containers, but I suspect that's similar to the informal trade answer. But perhaps you could say something about the typical routes and vessels.
On the typical routes for vessels, Jasper, if you want to say a few things there, more than happy to, because I know that you've been looking at this a bit more than both of us.
Yeah. So there are kind of two ways that you can have a look at this. So one, you could follow individual vessels in real life, just like their location. So we decided to only extract information within the port boundaries because we were only interested in that. But you could, if you want to, like follow the exact route and see where a vessel is going. But obviously this is a lot of information if you follow it already for maybe a couple months and it sends out messages every few seconds or minutes. The second approach, what you can do is say, okay, we have sort of like predefined routes, like a certain like maritime network, and from the data we sort of infer how much traffic is between two ports, and based on this sort of approach and like kind of routing it on the network, we can have some sort of estimates how on certain maritime transport legs the capacity employed is changing. And we actually did this in this work as well. We didn't have time to show it, but it shows this very interesting pattern where you can see that certain sort of connections between port in 2020 actually were decreasing in capacity employed, whereas other routes were increasing. So you can sort of like analyze how, you know, these companies also, you know, make some decisions where to employ more capacity and less because of this demand, the supply shock. So yeah, definitely feasible to do this.
And I guess that also says something about the richness of this as a data source, that you can look at it for the point estimates, the sort of call boxes or bounding boxes in ports, but also look at routes and transits and so on. Yep. We have one hand up from Sean. Sean, did you have a question? Do you want to come in?
Yeah, I just wanted to ask, I mean, thinking about the initial slide where you talked about data access, you mentioned non-commercial fees, you know, not wanting to. I wanted to get a feel for how, just if you had to think in a almost like a blue ocean, completely unconstrained mindset, if you had a wish list of supplemental data sources that you wish you could get access to supplement the analysis, does anything come to mind? I mean, you know, beyond you know, high resolution satellite imagery, if you had to go one step further by getting access to data, either data that you expect you wouldn't be able to see using some sort of confidential and computing environment, or something that's more standard, do you have a data wish list beyond this? I'm just curious because I happen to realize it is the AIS data that you're using, which just happens to be the data source in the global platform that is very, very popular. So I wanted to get a feel if we had to go beyond that. Thanks.
Yeah, maybe I can get that started. And it ties in with the previous question. What we discovered in this work is that the container liner shipping schedules are extremely informative pieces of information. It's not easy to put together, but once we were able to do that, we were able to see the routes of liner ships, container liner ships in the region. And it was clear that Fiji was the transshipment hub in the South Pacific and Guam was the transshipment hub in the North Pacific. And there were clear routes It was essentially feeder routes serving the two regions from out of those transshipment hubs. So if you ask me, I think that information in a organized, structured way would be one of my dream wishes for data. The second piece, I would say, that would be a dream wish, would be information on bill of ladings, so that we could tell a little bit more about what are actually inside the containers. So those would be my top two. I don't know if my colleagues have other thoughts.
No, for me, the second one is the main one. Like, we can sort of get a feeling how different economic sectors are affected by looking at different types of vessels, like bulk versus container. But in the end, you know, if we cannot observe what is in containers and how this sort of maybe sector composition of trade is changing in countries, for instance, which would be very valuable for, yeah, many types of applications.
Great, thank you, and thanks, Sean, for the question. There are other questions coming in, but I'm afraid we're running short of time, and I really like to leave space for some of the other speakers. So I think we're going to have to move on. But Serkan and Jasper and Robin, a huge thank you for a really stimulating talk. There's a comment in the chat that says this is astonishing. Thinking about the range of data sources that are now available to help us answer some of the questions that we've long struggled with, it is really exciting to see how AIS data is being used. So thank you very much for coming and talking about this. If any of you are able to stay on and just answer any of the other questions in the chat, that would be very welcome. Certainly points about bills of lading, which I know in the UK we're interested in, and there's the real export question, which in Europe and UK we often think of as the Rotterdam effect. So there's lots of interesting points here and spin-offs. So, but let me thank you very much, and if people are able to show appreciation using the applause reaction on Teams, then very welcome. But thank you very much.
Thank you. It's been our pleasure. Thank you very much for having us. Thank you.
Thank you all. Excellent. We shall move on after we've set the scene with some really exciting work here, and we're going to continue this, looking at improving agricultural statistics with Earth observations. So again, looking at novel alternative big data sources. The speaker is Lorenzo De Simone, who is technical advisor at the Office of the Chief Statistician at the United Nations Food and Agriculture Organization, or FAO. Lorenzo is joining us from Lesotho, so we hope the internet connection stays up, but we have a backup plan if it doesn't. Lorenzo, I can see you, so great to see you. All yours, and over to you.
Thank you very much. Tom, I will share my screen. Hopefully all goes well. Okay. So can you confirm that you can see the presentation?
Yes, can see the presentation. It's just gone into presentation mode, so looks good.
Okay. So let's get started. First of all, thank you for inviting me, and thanks particularly to Ronald and Sean and all the UN Global Platform team that has supported the FAO's endeavor in countries. So I'd like to talk to you about the use of Earth observation data for improvement of agricultural statistics and provide some examples from the experiences from FAO's work in countries. The presentation, sorry, I can't seem to change the page. Okay, the presentation articulates over 5 essential points. Why do we use Earth observation data? First of all, how does Earth observation data work in a nutshell? Which are the challenges? And how we overcome such challenges through the EOSTAT project and provide results from countries. So Earth observation data and geospatial information have been early recognized as instrumental to the modernization of national statistics offices and in support of the operational monitor of SDGs by the UN, so the General Assembly, and by the largest Earth observation coordination bodies, such as the Group on Earth Observation, the UNGGIM. And Earth observation, as has been said initially in the introduction, can be used both as a complementary or as an alternative data source to official statistics to produce a variety of statistics, such as agricultural, environmental, and other socioeconomic statistics. Which are the advantages of Earth observation data? Well, they cover a large geographic scope. They are provided with high spatial resolution, which allows for high granularity and disaggregation potential. They have a high temporal resolution, so frequent update, and they come at low cost. And as a final result, I think the most important impact is that you can get Earth observation-derived crop statistics earlier than the official statistics, from 6 to 12 months. How does Earth observation data work? Well, when the electromagnetic energy from the sun strikes the plants, you have basically three effects. It's reflected, absorbed, and transmitted. And the interaction between the three components can be detected by the sensor on the satellite or on a drone. And this relationship can be used to derive the signature, the spectral characteristics of the crops. So then what do we do next? Well, we gather data in the field, so the in situ data, which indicate the crop type and the location at known places. We combine these with the satellite images. We establish a relationship between the crop type and known location with the spectral information. And then we use classifiers, supervised and unsupervised classifier, to transform the entire image into a crop type map. And from that crop map, we extract the statistics, the acreage and the yield. But we need to integrate also a crop yield model on top of that map. But this comes with some challenges. First of all, the pre-processing of the satellite images is quite cumbersome. So we need to remove the clouds and the cloud masks from the images. And this per se is already a first barrier. Secondly, images don't come in an homogeneous time series because of the clouds, because of problems in the acquisition. So we need to recreate an artificial time homogeneous time series by carrying out gap filling and by creating so-called temporal composites. And hence we arrive at the so-called data cube and analysis ready data. Third, the volume of the data implied for storing and processing, of course, is huge. So for a country like Senegal, we're talking about 6 terabytes for each agricultural season. So for this reason, we are forced to use cloud platforms. But however, those cloud-based platforms, they just come with interface that allow for scripting, R, Python, JavaScript, and this can be another challenge to be overcome, another barrier. Third, I think it's the most important challenge is that the crop classification algorithms, they require a high volume of ground truth data, in situ data, for calibration and validation of the algorithms. Recommendations from GCAM, SIGUM, and Cent2Agri, for example, they advise to gather at least 100, 150 samples for each crop type, for each agroecological zone, and this can sum up to thousands of points. But in reality is that the in situ data is often scarce in countries, and when it's available, it's of poor quality, which makes it not really useful for Earth observation work. In this example here, we see some common problems in georeferencing. So in the top figures, we see GPS traces that contain more than the parcel's boundaries, and that creates a problem. In the bottom figure, it said we have a challenge to locate the surveyed parcel in the statistical database due to the fact that parcels are localized by geopoints, so we don't know to which parcel we refer. So FAO EOSAT project aims at overcoming those challenges. It was launched in 2020 under the leadership of the Office of the Chief Statistician, with the aim of building such capacity in national countries' offices. So some characteristics of the project. First of all, a tight collaboration with the NSOs in countries. DAPSA in Senegal, UBOS in Uganda, NSIA in Afghanistan, the Bureau of Statistics in Lesotho, and so on. So it starts from engaging with them directly to understand their requirement. Secondly, use and development of free and open tools with a graphic user interface so that we can limit as much as possible the need for scripting and coding on behalf of the NSOs. We use consistently the Cent2Agri system that was developed by European Space Agency within an international consortium, but we also work recently with EOSTAT Crop Mapper, which has been developed on top of Google Earth Engine for the time being. Establishment of international partnership is fundamental. So the UN Big Data Group, the European Space Agency, University of Louvain, Digital Earth Africa, and Group on Earth Observation. This to ensure countries to the access of free data, free tools, and the best methodologies, and to allow for the sustainability of the solution once the project funds are finished. The partnership with the UN Global Platform, which brings us, to today's topic really. So thanks to this partnership, it was possible to provide a secure and low-cost based solution for Senegal and Uganda. The UN Global Platform, which Sean is going to illustrate much better than I can just say that it provides storage and computing power and assures an optimal performance at low running cost. It's a scalable solution, and it assures the secure hosting of the country data. The last two aspects of the project. So we focus on in situ work, so improving the quality of field data, data gathered in the fields through optimization of the field survey design, introducing of best practices in georeferencing, deployment of pilot survey, and facilitation to facilitating the access to in situ data to the AGRIS and the 50 by 2030 initiative. And last, innovation. We also try to develop innovative methodologies, so more intelligent algorithms that can thrive on a smaller amount of in situ data. We will see that later. And the final pillar, of course, is the delivering of customized training together that is designed together with the NSO and provides training on the various segments of the full production chain of Earth observation data. So the remote sensing part, the in situ part, the application part, and the various technologies that are involved. Just an example, this was a webinar organized in Senegal. This is the presentation for Afghanistan and so on in Uganda. Results from countries. So first use case comes from Senegal, where FAO and DAPS have been collaborating since 2020 to develop the national crop monitoring system using Sen2Agri toolbox. As mentioned earlier, this has been achieved in collaboration with the University of Rouen and with the UN Global Platform. In fact, it was possible to deploy the Sen2Agri solution on the UN Global Platform. We delivered 5 training workshops. The national crop type map was produced with 20 type of crops and crop area indicators. An ad hoc survey protocol has been now implemented in Euro with the purpose of explaining how improved in situ data will lead to improved accuracy of the maps. And we also got sponsorship from Geo for Amazon credits. So this will allow for more sustainability in the future. What we see here is the annual crop type map at 10 meters. The granularity of the map allows us then to calculate acreage of crops at different aggregation level. And as you can see on the table on top, we can see the crop length, so the surface destined to crop activity at the district level. Or we can also do the same for crop types. So we can calculate the acreage at national level or district level for each crop type. And in the following chart, we compare the data extracted from the map with the official statistics reported in FAOstat. We can see that there is some good match on some classes, but there is quite a difference in the millet, for instance. And the divergence is really due to 2 factors. One, we don't really know the accuracy of the official data source, because there can be also an error there. But secondly, what we see is that our training data was not really balanced, in the sense that the number of in situ data gathered for the crop types are not balanced. So we have an over-representation of few classes at the cost of the minor classes. And this, of course, introduces an exaggeration factor in our estimation. So we over-represent some classes. And this is something that we're taking notice in our support to countries in improving the survey design. Next use case comes from Uganda, so it's very similar to the Senegal case. The scope is to establish a national crop monitoring system in the NSO that can be used to extract the agricultural statistics. The deliverables, so the Sen2Agri solution was deployed on AWS under the UN Global Platform. 5 training workshops were delivered. A crop mask was delivered at 10 meters. A dedicated field campaign was implemented independently of the annual agricultural survey. A field data collection in Bulindi, Zambia has been carried out just recently in February 2021. and this year, I mean. And finally, the crop type maps have been delivered at 10 meters, including pure main crops or also adding mixed crops with 2 different results, as we will see. This is just the binary cropland mask for a specific region. So it just tells us where we have crops and where we do not have crops. And in the north, we have a slight problem because there is a lot of natural vegetation which has been erroneously classified as cropland. And this is due to the fact that we did not have any in situ data in that area. This demonstrates that also the geographic distribution of the in situ data is very important. Finally, we produced the annual crop type map at 10 meters as anticipated, including the pure crops alone or the pure and mixed crops. Right now, we just visualize the map with the pure crops. Now, if we look on the left, we have the ground data distribution that was used for training the classification model. And as you can see, the mixed crops are on the right are yellow, and they're quite minor. So what happens is that this minority of mixed crops in the training data set and their specific mixture of spectral signatures is adding basically confusion into the map. In fact, if we assess the overall accuracy of the map when we exclude the mixed crops, we reach an overall accuracy of 79%. When we introduce the mixed crops, then it decreases to 72%. Third and last use case comes from Afghanistan. In this context, it was a bit of a different situation because Afghanistan was already using Google Earth Engine and they wanted something to be deployed there momentarily. So we converted, let's say, the scripts that we are using in Cent2Agri for the crop classification into Google Earth Engine. And plus, we added some innovation in the sense that we're using also a semi-supervised algorithm called dynamic time warping, which allows user to classify crops also in those situations where we only have few in situ data. As a result of the project, so the application was developed, a crop type map and acreage statistics have been produced first for the Turkestan Plains and then for the entire country, and 2 training workshops have been delivered. And now we're thinking of ways to migrate those scripts on the UN Global Platform. There will be technical discussions to follow up on this. The project came to a stop after the change in the political aspect of the country, but recently we received confirmation from NSIA that the project can continue. We're very happy to hear about that, and currently a field survey should start, so we just finalized the agreements this week with the NSIA. Last 3 points for reflection. What could be done to improve the system, to push the boundaries to have better estimates, more accurate estimates? So probably the introduction of ad hoc surveys which are optimized with Earth observation data that are integrated within the National Agricultural Survey plans. They should require minimal efforts. They should be optimally designed based on certification, and they should include and ensure best practices in georeferencing. Second is the improvement of the transferability of the learning of algorithms, so that an algorithm that is trained with data from a specific site for a specific year can be used to predict crops in a different area or for a different year. We are still not there. Research is moving towards that direction, but it's still, let's say, a hot science topic. And finally, the development of graphic user interface, which could be task specific on top of Earth observation platforms. We know the most common ones, because we believe that the requirements for scripting and for coding, it can be quite an important entry barriers for NSOs. With this, I stop here and I thank you very much. I hope I am within the time allowed. Thank you.
Lorenzo, that was perfect. Thank you very much. And very, very interesting to see the work going on here and the challenges about using a new data source or a novel data source, for example, where areas where you're over or underestimating or merging or not identifying particular categories. So really interesting to see how you're ground truthing and comparing, validating with other sources. So literally on the ground field surveys. Colleagues, any other questions from the chat, or please raise your hands. Lorenzo, I think you could probably stop sharing your screen. I'm seeing myself in about 4 places, which is more than anyone wants.
Okay, I don't know how to stop sharing from here.
That looks good. We can see you now. Thank you. There is one question that I'll answer while others are coming in. We will put all of the presentations, the slides, up on the website so that you will be able to view them after. Plus, this video will be put up there once the technical people have managed to sort that. Are there any direct questions for Lorenzo? I have one while people are waiting. I wonder if you could go say a little bit more about the ground truthing and the comparison, the validation. Is it your view that we will always need, for every country, every area, follow-ups, field surveys, validation, or do you see that over time our understanding, our use of the data will improve enough that we will have confidence? And I guess that's a question about assurance and confidence in the source and our analysis.
Well, in my view, we're going to require probably less cost-intensive surveys, but we will always need some type of ground truthing. Okay, crops are not like vehicles, are not like urban, are quite dynamic. You know, you can have mixed crops, you can have rotation, you can have introduction of new crops. All of those variables, they need some sentinels on the ground that can inform about that, first of all. Secondly, the anomalies that come with crops, late onset of the season because of late rainfalls. So the anomalies not just in the type of crops that are cropped, but also in the shift of the season. So for instance, the use of other algorithms such as dynamic time warping, they try to deal with the shift in time series, so in the phenology of the crops, and try to match that with the remote sensing time series. And that's one way to deal with it. There are also other more efficient way to gather data in the field. So there are sensors, you know, the screen shield surveys that you just drive along with your car. There are ways where technology can make this faster and less costly. But in my view, we will always need to have a link which can be reduced, as I said, in volume and costs.
Thank you, Lorenzo. What a question from the chat. What are the research frontiers you want to continue exploring once more detailed data is available?
Well, it would be interesting, for instance, to see how early we can predict crop yields, how early before the harvest. So how can we push this as early as possible? That would be one thing. Secondly, a second thing is to really push the algorithms to function with I don't know, 1-2 samples for each crop, for each agroecological zone. This is what we are trying to do in Afghanistan, although we do have a survey which is going to gather some 3,000 points because they are allowed. Then what we are testing is, okay, out of those 2,000 points, can we just use 40 points and get the same estimates that we would get with a random forest that uses all of that? So I think that's where the research is really to see when we can stop and say, okay, below this amount of data, the results are going to be really too much off.
Excellent, thank you. There's another question coming in from the chat around spectral bands and the data stream, I guess. But presumably different crops look very similar under broader spectral bands. Is the higher resolution data for fine grain spectral data in future, or are there developments there that you are looking to help unpick some of this?
Okay, I hope I've understood well the question. Is there also higher spectral resolution data that just brought? Okay, so yes, indeed, there is very high resolution data. There is also hyperspectral data, which means that there are more bands. So there's higher spectral resolution. The problem is the costs that comes with them for the acquisition and for the computation of those data. FAO is, of course, looking forward to solutions for countries. And in this context, we try to find solutions which are as much as low cost as possible. In the specific case of Afghanistan, the country had established a long-term agreement with Planet Data. So there we work also with data at 4 meters, which improve the capacity of recognition of crops. I would say that another issue of crops is not just the similarity, but it's also in the tropical countries where you have a lot of cloud coverage. You don't see the crops using optical data, and therefore you resort to radar data, so active sensors, and that introduces other type of complexities because the treatment of radar data is a bit more complicated than the optical data.
Thank you. And 2 more questions, and then I think we'll probably need to draw it to a close. Could you say something about your experience around regions with a high mixture of crops, 4 or 5 crops, particularly where you've got different sizes, where long ones can hide short ones? So something there. And then more broadly, is there a plan or thinking and discussions across FAO to create a global gridded data set for crop types, crop production, etc.?
Thank you. So regarding the first question, it's very controversial topic. There are some local projects which use hyperspectral data, which are able to detect the different type of crops, or there is also LIDAR data which detects the height of the crops. But establishing that type of service at a national level, I see it very difficult in terms of feasibility and sustainability. But right now there are pilot projects from many realities in research, but also in commercial for precision farming that can afford that. The issue with the mixed crops makes me also think of the issue of smallholders. So we talk about the size of the plots. So with Sentinel data, which is free and open, which comes with a 10 meters resolution, so we are able to map also 0.3 hectares down to 0.1 hectares of land. We can discriminate it. So it works for small plots, but anything smaller than 10 by 10 meters cannot be detected using free and open data. So that requires some thoughts about it. There are initiatives to make commercial data freely available for some specific countries for no-profit purposes. Regarding the future projects on global crop mapping, so we have established a memorandum of understanding with the European Space Agency. This year it was signed finally, and we do have some streams of work. One of those is the collaboration on the global cover projects of European Space Agency, so the World Cover and the World Serial project, which are geared to pilot the feasibility of having a global land cover map at 10 meters. I think it's going to be presented tomorrow, the results. And the World Crop, which is about mapping. I think it's maize. I don't remember which is the other type, but it's really a prototype. So we have been thinking on how could we scale up the actual production of a multi-crop global map. So we're thinking about this jointly with ESA. So for the time being, we're just collaborating to the World Serial by sharing training and validation data, but we're certainly thinking of these for the future. So that's the direction. Thank you.
Excellent. Lorenzo, thank you for the presentation and for talking us through a really exciting area of data use. Lots of challenges, but really great to see some of the work going into this and some of the thinking going into this. And if you've got a chance just to look at some of the comments on the chat, what I've found really interesting is the variety of other groups, other users, thinking about similar approaches for their area of interest, which really to me underlines the point about community. The big data and the data science group here is a community which shares expertise, shares our experiences and so on, and where possible makes methods open and reuses those methods. So great to see an example of that in practice. Folks, if we could do a similar kind of thank you to Lorenzo, and team for all of the work and presentation. Thank you, Lorenzo.
Thank you. Thank you.
Excellent. Okay, right. We're going to go on to something a little bit different now and look at the platform itself. With a demo of the global platform. But before we do, we have a second video, in this case put together by Statistics South Africa and colleagues in the UN Committee of Experts. And I would like to really thank the South African Statistics Group. Rusenga Malaleke is the chair of the Committee of Experts here, and his colleague Ashwal Jenica leads on the Finance Committee for the UN Global Platform. So lots of support and input from that group. So thank you very much. And perhaps we could line up the video. Clarence, you're on the case. I can see it. Over to you. Thank you.
This platform is a cloud-based data collaboration environment, which contains global data sets, new methods, and advanced technology tools for the common good. And it is available to all institutes of the statistical community and their partners around the world.
Using big data in combination with traditional data sets is essential to the analysis of inequalities and vulnerabilities in our societies. Using all data sources with real-time analytics could provide insights into public health situation, agri-food systems landscape, and financial inclusion programs.
I would like to emphasize the importance of global collaboration in the area of data innovation. To fully exploit and benefit from the possibilities of big data, we rely on active collaboration of statisticians, data scientists, data engineers from the statistical community and from academia, private sector, and non-governmental institutions. We have embarked on a global training program to improve the skills of staff in statistical offices so that each office can participate in big data projects. The recently created regional hubs of the United Nations Global Platform in China, Rwanda, the United Arab Emirates will help in the delivery of these critically important training activities.
This day it has produced handbooks as well as training materials which provide guidance on the use of big data, satellite data, mobile phone data, as well as scanner data. Training in the use of big data as well as in data sciences is needed for all statistical institutes.
Let me mention about the United Nations Global Working Group on Big Data. Under the umbrella of this working group, many experts from all stakeholder communities are already working together. Several collaborative data projects are currently being executed on the United Nations Global Platform, and we are inviting you to join this work.
Many thanks. Great to see that. And that really sets us up for the next item. And I would like to hand over to Sean Lovell at the UN Statistics Division. Sean is going to take us through a demo of the UN Global Platform and works in the Information Systems team at the Data Innovation section at the UN Statistics Division. So Sean, over to you.
Hey everyone, and thanks for having me. I'm really happy to be here. I just wanted to introduce myself. I'm Sean. I work with Ronald, part of the what we the UN Global Platform team here at the Statistics Division. Let me share my screen first. Started. All right. Okay, can you see full screen mode?
Yes, looks good.
Okay, awesome. So, yeah, a little bit of background. So I'm actually, so my original background, I'm an economist by training, and I moved into statistics, and then I moved into, software engineering, and so I've sort of entered a very new place over the past at least 5 to 10 years. So I'm really happy about this, but that's led me to a lot of really interesting things, including the global platform. I just want to give a big picture before I jump into the demo. So the global platform runs two kinds of services, and I've sort of broken these down from my own understanding. We have specific services for the statistical community and users at large that prototype innovative methods and software. And these are the things that produce what we think of as statistical assets. Estimates, you think of the sent to agri crop maps that Lorenzo has put together. We have other projects that are really geared towards the dissemination of data or certain types of SDG applications. And these are geared for the public at large, if you will. And this is not what I'm going to talk about today. What I'm talking about are what we think of as the developer services that are used by the global platform project teams. When you think of the data access components, we have different tools for managing code. We have sort of a cloud native serverless environment. We have a notebook environment. So we have a range of services that we offer to the global community, to the people that would be creators of these innovative methods, if you will. The teams, you think of, Lorenzo, he put a lot of effort into this crop mapping project, and he made use of many different technologies, and one of them was, some of the things we had on the platform. So this is, if I had to break it down, so the developer service is the focus of this presentation. And so the vision for developer services, I sort of put this, I hope it summarizes what we all see, is we want to increase the pace of innovation in statistical offices by providing access to state-of-the-art tools in data science, software delivery, and cloud infrastructure. Whether it's direct access to Google Cloud or Amazon, or whether it's sort of an architectural contribution where we build a bespoke system or something like this. But we would like to expose our teams and statistical offices to more state-of-the-art methods and tools. So we have, at present, we have several entry points, if you will, to the developer services. And we have the core services. You can think of these as the things that have been around for a long time and are well established. The notebook service, this is where, for instance, this is how you would get access to the AIS data in the Spark environment. We also have a code service, which is a Git-based code collaboration environment, based on GitLab, self-hosted here at the UN Global Platform. And this helps us do things like manage projects better, interact, collaborate on a code-based environment, and so forth. We're always looking for new services that help the community that end up either being valuable or not. So we are looking into new tools that help deploy in a continuous delivery environment, or things like AI, ML ops services like Kubeflow and so forth. So we are experimenting and trying to prototype these. So the idea is we use these to run the projects deployed on the platform, and if we find them useful and we can make them multi-tenant, we open them to the public. So these are the tools we use in-house to run projects, and we'd like to share the love, if you will, by allowing the public at large to use these as well. So this is the rationale behind this. We adopt the new technologies that work and open them to the community. So why did we create a developer service? We needed a space to collaborate and learn with a low barrier to entry. Things like sharing new data and methods, just experimenting with new technologies, deep learning, Spark, and having a suite of self-service tools that you can use from broad network access anywhere on the planet, makes it much easier to conduct trainings, to experiment, to share, and so forth. So it lowers the barrier to entry quite significantly. So it also helps to reduce a lot of the risk that comes with direct access to some of these cloud services that you incur. If you would like to open up broad access to the public at large, it helps to have layers on top of these services that help manage cost and reduce the complexity. So we've been experimenting with some of these services. So this is the rationale, if you will. So I'm just going to quickly get into some of the demos. So we have the first one I'll just show is the notebook service. So this is a self-managed Jupyter Hub deployment on Kubernetes. Many of you may be familiar with the code base. It's the Zero to Jupyter Hub code base. So we've basically forked this and used it for our own services. It's a remote Jupyter Notebook computing environment. You can run Python code, R, Scala. It scales sort of based on Kubernetes, so it'll scale as needed. So if you log in, it'll create a new server for you, so you can run the code in the browser. And it's the main point of entry for access to AIS data and some of the Spark Analytics functionality that we have. So now I have to change screens. I just want to quickly show what that looks like. Okay, so I'll just share everything. So this is the in the interest of time, I've already logged in and loaded up some environments, and I have to say, I'm not a user of the AIS platform, so I wish I can't run queries to show you how that works, but I did want to show you the general entry point where you would basically that you would see. So when you come to the Jupyter environment, maybe if you're familiar with Jupyter, it's just a simple way of writing code and Markdown together to create sort of an interactive paper, if you will. It's based on the idea that text and code should co-mingle quite happily. So in the global platform environment, you would use these Jupyter notebooks to access the AIS data, run different queries. So you can execute code in the browser, and this is generally how it works. So I'm not going to go into too much detail right now on the Jupyter environment, but you can. It's a very standard interactive setting for code, and you can. I could almost show. I want to see if I could log out and show you what the login looks like. So when you log in, you should get access to the ability to close. See if I can stop. You can stop your server. And this will stop the underlying Kubernetes server that's running there, and you'll be able to you'll reach a page like this where you can choose which okay, so starting launch server. So this is right now, these are the options we have. So we can customize this as we like. So each of these corresponds to a pre-made computing environment. So this is our data mechanics partner. They administer our access to Spark, and we have within this Spark cluster we have access to the AIS data itself underneath. So this is how you'd access. So this one you'd select for AIS, and this would be for standard data science. You can imagine you can customize the amount of CPU you want. Right now it's running at a fixed level. So that's the notebook service. The code service I wanted to give a demo for as well. I'll just quickly full screen here. So it's a code collaboration environment based on GitLab. It's something that I feel if we had to break down the core capabilities of data science in the 21st century, writing using Git and Git-based collaboration tools is just fundamental. So this is something that we've discovered is a very important first step for a lot of teams when you're trying to collaborate across time zones and internationally with partners in different institutions. It helps to be able to work asynchronously. Again, Git-based collaboration tools like GitLab help you do that. So I'll have a demo of how we use this on a particular project. But the great thing is, all the features of the self-hosted GitLab are free to us to use, so we don't have to worry about how many times we run a build job or something. It's all something we can sort of handle on our own, which is important as well. So this, if you will, it is this environment. So if you're familiar with GitLab, this is should be very familiar. We use this to write code, to collaborate on projects. So we have. I'm not going to go into the details of this too much, but the power of something like GitLab is that you can basically integrate project management with the data science work itself. So, if you're familiar with this should be very simple. But it's very important when you're working on data science projects to be able to collaborate in this environment. So, this is a project that we've put together on the linked SDGs. So we've just. I'll go to this in the next slide, but I just wanted to show how this all kind of came together. So what we found that we had a project in-house basically where we had several microservices that we had built, and we had a really interesting proof of concept application that several from our division had put together, and we had to find a way to give this a life beyond just our local computers. So this is hopefully, this is a recurring problem, I think, in a lot of organizations. I hope not just the United Nations, but access to the right tooling was something we hadn't thought about initially. So luckily, we did have access to the global platform, so we were able to make use of the code service, which was one of the key services. So we used the code service for collaboration. We used it for building project assets. We had a lot of automated build jobs that ran. And because we built to containers, we deployed to Kubernetes, and we were able to use another service on the platform, which is something, if you think of it, it's almost a closed beta service, but access to the serverless Kubernetes environment that we use. So this is something that was a very powerful complexity reduction process for us. So we were able to take this project, integrate it using the code service, and deploy it to the global platform. I'll just show you what that looks like. It's not the focus of today's talk, but just to give you a feel for, this is an application that's several others put together that helps to analyze documents. So you can, we could pick a new link. We could say, Le Monde. We can go to the French newspaper, and we can pull a link. You can say changement climatique. Take that, and we can basically try to extract we want to see what the concepts are in here, what the SDG. So this is I've never seen this before, so this is a new one. So okay, it says it read the article. It says you have climate change, and these are actually established vocabularies, if you will. So the challenge was to try to use ontologies and try to link these established concepts that are in the document itself to SDG goals. So this is, so you can see this. You have the concepts that are in the document. You have the geographic areas. So there's no AI here. This is just text extraction using ontologies. So you can think of it as showing the, if you had no intelligence or no artificial intelligence and just ontological modeling, how would that work? So here it extracted some geographical areas, and then it basically also showed you what SDG goals are relevant in the document. Now, of course, this is a rough estimate, and you can actually look at these and try to, let's see, SDG 5, some maybe here 9.4 to hunger. You can actually look at some of the SDG data. Hopefully that's not going to crash on me. So just quickly setting that aside. So that's an example of how we've been able to make use of some of these tooling. And I wanted to sort of end on a more interesting note. So how do you get involved if you wanted to get access to the AS data or to any of these other services, or to express an interest in a new service or anything? You would write to support@officialstatistics.org, or you join our Slack. And so this is a great way to communicate with us, because we are here to serve the community, and we would like to really get feedback from others, just understand what what the needs are, where the users would like to see new features, and so forth. So from my side, that's all I have. I hope that has been useful. Over to you, Tom.
Sean, thank you very much, and really fabulous to see some of the platform in action, and to see how you're building and how others have been building some of the tools into the system. So folks, really do pick up with Sean and team at UNSD if you'd like to find out more, and I'll just kind of put more comments in the chat. But in the interest of time, we're running over a little bit. My apologies, that's my fault as chair. But let us go straight on to the final presentation to look at some of the questions about the future of the UN Global Platform. And let me hand over to Robert McLennan, who is Chief Technology Officer at Statistics Canada. Rob, all yours.
Thanks very much, Tom. I'll see if I can keep this brief, but to the point, and then maybe stimulate questions. Okay, so hopefully you can see that now. Yes. And allow me to put it in slideshow mode. So I thought I would speak today and just say a few words about some of the future direction of the platform. We've heard a lot of really great things so far about some very specific activities that some of our task team partners have done. In addition, Sean has given you a bit of a demo right now of what some of the platform elements look like. So I'm going to take it up quite a level of sort of detail and talk about a couple of the key trends. We know why we're here. We've heard this in a number of different ways. We've seen a couple of different videos on it. The platform itself is complementary to the work of the task teams. If the task teams aren't here, then obviously we're not getting that kind of drive of new needs, new requirements, new software, new data. So this is a list of the ones that we're working with, and you've heard from a couple of folks that are working with some of these task teams today. Earlier it was mentioned that we have both the actual global platform itself, so sort of the central one. We also have regional hubs. So we have colleagues, some of whom are on the call today, and of course our hosts. So there's work underway to launch regional hubs in Brazil, in China, in Rwanda, and of course in the UAE with Latifa and her team here. And really we work in a cooperative fashion. There may be some things that are unique, if you like, or special about some of those regional areas. It could be which cloud service providers they choose. It could be a host of other things. And so as we continue to go forward, really what we're looking to do is to ensure that the kind of methods and data and tooling is portable amongst these environments, and that we really ensure that we don't have any sort of artificial barriers between their ability to interoperate and to integrate. They work in an autonomous fashion. We have overall governance, and so representation on the technical delivery board from all of these folks as well. Key elements, I was reflecting over some of the videos from earlier this year, some great stuff from Tom and from others. You know, we're all about the data, we're about the methods and community collaboration and expertise. I think the important thing to stress here also is the leave no one behind aspect. So as we go forward, we will work to continue to ensure that we're not actually creating artificial access barriers, either through, you know, adopting software that isn't going to be accessible, for example, or, you know, to which people don't necessarily have a lot of knowledge in different areas. So again, these are some of the key principles. I think that some of the key supporting elements here then, we've got the infrastructural aspects, we've got the tool pieces, and you've seen some discussion or mention of tools today, everything from things like GitHub for collaboration and managing versions and so on of things. And then the underlying infrastructural elements. I think as we continue to evolve the platform, we're always casting an eye to who the actual users of it are and also what their journeys are. So, you know, there's a wide variety, and you've heard from some of those folks this morning. But I think that, you know, also similarly, we're looking to ensure that people like developers and other data science aspects can actually work effectively and contribute to the platform, potentially at a technological layer, as well as also, you know, the primary purpose, which is really to get in there and do data analysis, processing, generate insights, collaborate, co-develop methods, and so So today we are running on a number of cloud services, so all of the big players. And we continue to evolve what that story looks like. I think that the global platform itself is predominantly hosted on AWS, and there are other activities using some of these other areas. Sean has touched on some of the key services, developer services, so I won't talk about that, other than to say that, you know, in future what we look to do, driven by the work that various people are doing from the data science and testing communities, we add additional developer services as we go. So it's very much user driven. And then there's a whole host of underlying support services. We continue to fine tune those and evolve them. So that's really what's happening there. We have heard a lot about the AIS data, which has been a very successful component on the platform, OSOL Earth observation data. And, you know, there's also synthetic data that's available on the platform. Again, this is driven by our partners in the task teams. Right now, one of the key elements that we're focusing on really is the notion of data as a service. So how can we actually grow the value of the platform by actually growing the amount of data that is available to people? And this is going in a couple of different directions, and I'll say a bit more about a couple of considerations from that. If we say, well, what are we going to do with this data? I think that there are a number of possible areas that we can focus going forward. Some key messages that have come out of the work with Earth observation, this into Agri and other things, is really around the need to be able to continue to create effective data engineering pipelines, automating, streamlining, reducing manual touch. I mentioned the data as a service piece, so that's the Smart Data Hub activities. I think there's a broad category of data stewardship that we continue to invest in. So this ranges everything from data cataloging and intersection with other data catalogs that are out there, as well as also in future, what are the roles of some of the data standards and how do we actually embrace those? So for example, we host .stat for CamStat on the platform, and it actually implements a number of things from the SDMX standard. As we shift the data and broaden, we get into both proprietary data, and that got mentioned earlier, I think, today, and then also personally identifiable data. So obviously that raises the need to ensure that we've got strong access control on those particular things, and that we're protecting privacy and confidentiality as required. We can't just afford to move the data, you know, all over the place. So again, it's about making effective decisions around where data is situated, how we actually can do a distributed algorithm execution potentially, some data mesh conversations, data virtualization. So these are all things that are on our radar for the future. I think the data lifecycle management element also is, you know, if we're dealing with big data, there's a lot of data to be actually dealing with, so we get into issues about how to actually effectively manage it throughout its lifecycle, and provenance and lineage conversations. If I move to the next slide, then we have a host of projects. I think in the interest of time, I won't go through these. We cross a lot of domains. You've heard about a number of these things this morning, and you know, the projects keep growing and the things evolve. We have a number of proof of concept activities. So the way we work with the platform is that people can propose proofs of concept, and we review them at the technical delivery board and you know, give our blessing to continue with them. So if you have ideas out there, by all means approach us. This is a list of some of the ones that are underway. You will have heard of some of them again, I think, on the call earlier this morning, and in the interest of time, I won't go through them all. But you can see again that we've had some really great success with AIS, and we continue to look at how we can actually extract more value from those data sets. And then and more. So earlier I mentioned that as we look to get into more sensitive or more confidential data, so one of the things that we have in the UN Global Platform is the privacy preserving techniques task team. There's an original handbook that's out now. There's a second version, I think, that's about to be released. And so again, key focus here on input, output, and computational privacy. The techniques that get identified here, I fully expect will be ones that we adopt in time in the platform. And so again, we really just need to make sure that we're honoring our obligations in terms of the actual sensitivity of the data that's there, obviously backstopped by cloud infrastructure services and identity. So I think we use Okta for that right now. I would be remiss if I didn't say that, you know, in offering a platform, you can use it well or you can use it carelessly. We want to encourage exploration and investigation and original research. And at the same time, we obviously have to live within our means. So cost management and scalability, I think, are key. We want to have, on the one hand, the flexibility and capacity within reasonable boundaries to make the platform grow. We continue to use a heavily Docker and Kubernetes-oriented approach, cloud native activities in terms of actually implementing controls. We have, I think, demonstrated some important scalability, but we have to make sure that we can also put some bounds around, you know, how many GPUs can you dial up and how long can it run? And you can spend a lot of money pretty quickly in the cloud if you're not careful. So again, this is an area of further work on our part. We have an awful lot of investment in open source and cloud native technologies on the platform. We are open, though, in areas. We do actually have commercial platform things. For example, we've worked with Algorithmia in the past. So again, it's a mix of solutions to meet the needs of the community. Very quickly, I thought I would throw this in that I stole from the European Interoperability Framework piece. I think, again, as we look to put data together, we can think of researchers and data scientists and technical people making these things happen. Obviously, there's a lot of other things that happen in the background as well, in terms of both ensuring that the data that is integrated is of high quality, that the answers that you generate with those are meaningful and are suitable for making important decisions, if that's your purpose. I think the other thing is that, again, there is variability. We've had a sub-team of the privacy preserving techniques task team looking at trying to come up with some general guidance around privacy and related legislation on a global level. And so I think one of my last comments here then really is around the linkage to training. So the platform itself has a technical community that supports it, that grows it. We have people contributing from different statistical agencies. We're always looking for more. I think that I was looking at some of the work that had been done on some of the training task team stuff. And I think, again, I just wanted to draw a strong link that says we're looking to both have access to and or develop the technical roles that are part of the platform, as well as obviously the big data piece. And again, I think that folks working with us on the platform, it could be a very effective partnership to contribute and also learn additional skills from each other as we go forward. And this will ensure that we have a viable future in terms of actually being able to support its community support model. So I think that that's it for me, Tom. I'll stop. Carpe diem, as they say. So I encourage anyone who's listening to join us on this exciting journey. I think that, you know, if you think back to the start of all of this activity with significant contributions from the Office for National Statistics in the UK, the great colleagues at the UN and working with people from around the world, I think that this has so much promise, and I really encourage you to reach out to the players here today, either to contribute at the technical platform level or, importantly, to be part of those research communities. Back to you.
Rob, thank you very much for that, and great again to see the thinking behind the technical work and the platform and the thinking around what comes next and so on. And I think you kind of sort of made some of my final closing points, which are very much around this is for all of us, and please join us on the journey. So let me kind of just wrap up. We've run over time a little bit, but I think I hope that you'll agree with me. It was well worth sitting to hearing some of the examples and some of the experience and some of the work going on, and hopefully that sort of triggered interest in you to follow up and start thinking about how you can use this in your organizations and some of your work. So let me make 4 closing points and to wrap up this first webinar on the road to Expo 2020. And first is that big data, along with other sources of data, government, survey, and other, is a really important tool. It helps us understand and shed light on how we understand the economy, the world today, and so on. And what we've seen here is that this is really a community operation. all of us are trying to understand the same sorts of issues, same sorts of challenges. We have similar questions. And so sharing experiences and sharing infrastructure like the platform and sharing our understanding of what works and what's useful is absolutely critical. So thank you all for kind of joining us in this session to share experiences and listen to some of the work going on. So that's my first point. Second point, Sean talked us and walked us through a demonstration of the UN Global Platform. This is infrastructure that is for all of us. So the data, the methods, the tools, all of the things that Sean talked through are operated by UN Statistics on behalf of the global statistics community. So if you want to get involved, please do. And if you think actually there are data sources there are tools and techniques and methods that I would really like to explore using in our organization, then please do follow up Sean, with Rob, with Ronald and others. And again, this is for all of us. Do get in touch. Please join us on the journey. Third point, this is the first of 3 webinars. Now 4, I gather, which is great news. And so coming up next, there is a session on methods and applications. That's on 9th of November, led by Esperanza Magpante, and it will include presentations and demos from the task teams. So some of the work we heard about, particularly looking at mobile phone data, privacy preserving techniques, and retail scanner data. Second session follow-up is on training and capability. That's the 23rd of November. That's led by Dominik Ruskrut and Statistics Poland, and that will look at competency and skills for data science using big data, maturity matrix to think about in your organizations, and big data training curriculum and signposting resources. And then the final one will be on big data and the SDGs. Clearly, we've heard a little bit about some of the tools that you can use to look at text and then link those directly to SDGs, but there's a lot more going on. That's 14th of December and will be led by Niels Plug from Statistics Denmark and Vice Chair of the Committee of Experts. So please do look out for details on those follow-up sessions. And then also the face-to-face, the festival as part of Expo 2020 that Thuria talked about in her welcome. That's on January the 19th next year. And final point is to thank you and to thank others. I'd really like to give a huge shout out and thank you to the UAE team for hosting us and for supporting on the Road to Expo work. I'd really like to thank all of the speakers who've spent their time and come along and talked about their work and talked us through some really exciting and important program of work going on. All of the colleagues at UN Statistics and the Committee of Experts on Big Data and Data Science, thank you very much for your input and support as well. This is a truly global experience and a truly global effort. So thank you again, and please do look forward to continuing that work with you all. And then finally, all of you, thank you for attending and for the comments and questions in the chat. Great to see the interest and the enthusiasm and the links that you have drawn between this and your work. So thank you all, and I hope the rest of your days go well. Thank you from the UK and from the UN Statistics Group and from the Committee of Experts. Look forward to seeing you on the next sessions. Thank you.